Good day, everyone. In this video, you're going to learn all the different types of combinations of naming ionic compounds and molecular, also known as covalent compounds. All right, let's do this. Hello, I am Joanne Cici Nampan, an advanced chemistry teacher and willing to help students like you understand what you have just learned in class. So, you could finish your lessons in advanced chemistry. Why? Because this is very important lesson. Because you will be naming compounds until the end of the school year. And if you decide to continue with chemistry, you will be naming compounds forever. So if you need to pause, replay, or write anything down, please do so. I'll be letting you know what you need to understand versus what you need to memorize. Okay, here is a simple strategy that has helped my students remember how to name compounds correctly. The strategy is to identify the type of compound from the very beginning, whether it is ionic or molecular. Molecular refers to covalent compounds. An ionic compound consists of one metal and non-metal. A covalent compound consists of two non-metals. Looking at the periodic table, the highlighted portion shows you all the different types of non-metals. Everything thereafter then is a metal. We'll start with the different types of naming for ionic compounds. Aluminum oxide shows you the name of the metal, our aluminum, and oxygen, or our non-metal ending in "-ine". Looking at the periodic table, we need to identify our charges. So if you have to pause the video and write this down, these are the charges that you need to have memorized. For ionic compounds, you will always have to balance out your charges. For this example, aluminum oxide, let's identify the charges for aluminum and oxygen. Aluminum's charge is 3 plus charge, and oxygen has a 2 negative charge. Aluminum had the 3 positive charge and oxygen had the 2 negative charge. Let's balance these charges out by multiplying our aluminum, or really placing a subscript of 2, and that 2 then multiplies with our 3 positive charge and becomes a 6 positive charge. We want these charges to be exact or the same. So, I will also then place a 3 subscript that would then turn this 2 negative to a 6 negative charge, and our charges are balanced. Another way of looking at this is what we call the crisscross method. In the crisscross method, aluminum gets the 2 and oxygen then gets the 3. They get the opposite charges of each other, just so they can make the same or exact charge. They would then cancel the charges and be neutral. And our final balanced compound is aluminum oxide, having that subscript 2 and 3. The second one is ionic compound with a transition metal. This consists of the name of our transition metal, a Roman numeral in parentheses, and a non-metal ending in I. In this example, we have what we call the iron 3 oxide. In this 3 iron oxide, our transition metal is iron and our numeral is 3. Your Roman numeral actually tells you the charge of your transition metal. A lot of times, transition metals have different types of charges. Iron sometimes has a positive 2 or a 3 positive charge. So our Roman numeral actually tells us the charge of the iron and is within this compound. So your non-metal is the oxygen, and once again, that ends in I. So we need to balance out our charges. So let's go back. So iron then has a positive 3 charge, and oxygen has 2 negative charge. Balancing out these charges will place a 2 subscript for our iron and a 3 subscript for the oxygen. We know we have these 6's canceling out, which is what we wanted, and your final compound is F2O3. Next, we're going to have the ionic compounds with polyatomic ions. Polyatomic atoms just means that there are 2 or more elements within that atom. You know these polyatomic atoms. In order for you to memorize it, you can write it down in an index card or in a flashcard in order for you to remember all of them. Moving on to the ionic compounds with a polyatomic atom. They consist of our metal and polyatomic ions or polyatomic atoms. Notice in the example of the common polyatomic ions, notice that you do not have your non-metal ending in I. A lot of these polyatomic ions or atoms end in what we call ate or ite, with the exemption of hydroxide and cyanide. So, we have an example here. So we have calcium phosphate. Calcium is the name of our metal, and phosphate is our type of polyatomic atom. Polyatomic atoms do have specific charges. So that is once again something you do have to know. Calcium has a positive 2 charge, while phosphate has a 3 negative charge. Our phosphate started off with having 4 oxygen. So to balance our charges, we need to place this in parentheses to isolate the phosphate group. Doing so, we'll place our 3 with our calcium that once again give us a 6 plus charge. We're going to place our 2 on the outside of the parentheses. So polyatomic atom tends to have parentheses whenever we have placed a subscript. These are now balanced, and your final compound is calcium phosphate. This is how it's properly balanced. Our last ionic compound mixes transition metals and polyatomic atoms or polyatomic compounds. It consists of the name of the transition metal, a Roman numeral, and a polyatomic ion. Here, we'll see copper 2 once again. The 2 tells us the charge of copper, which is our transition metal, and our polyatomic atom of nitrate. Nitrate is NO3 and has a -1 charge. We saw that copper had that 2 positive charge, so all we need to do is just have a 2 for our nitrate since copper is already 2 balancing out our charges. We will place this in parentheses and place our 2 subscript outside, and we'll have these 2, or we're going to cancel these 2. So your final compound is copper nitrate with the 2 subscript only on the nitrate. So let's start with going backwards now. So instead of having the compound name, we're given the formula and asked to actually write the name of the compound. So we're going to have FeBr2. Fe is known as the iron and Br is known as the bromine. Iron is a type of transition metal. Bromine is a nonmetal. So our nonmetal will end in I, and we know that the transition metal will have a Roman numeral. So to figure out what your Roman numeral is, let's go back to the overall charges. So the bromine is a type of nonmetal, or a halogen, just meaning that it has a -1 charge. So since this had a -1 charge, Fe or iron must have a 2 positive charge. And another way of identifying this is if we were to go backwards, these 2 would go back onto the iron, since bromine needed 2 to balance out the charges altogether. So we'll have iron to bromide. So let's try another example. Example is we have Cu3PO42, in which we have the Cu there is known as the copper, and it is a type of a transition metal. So we have to have a Roman numeral. So PO4 is a type of a polyatomic ion. So we had to know that the polyatomic atom charge was a -3, because this is then allows us to figure out that copper had a +2 charge. Another way of looking this 2 goes back to the previous element, so that 2 belongs to the copper. And this 3 then belongs to our phosphate group. So that trick that you can use whenever you're using your formula and you're trying to go back to the actual name of the compound. So our name of our compound would then be copper 2 phosphate. So those are all the different types of combinations for ionic compounds. Moving on to covalent or molecular compounds. Something that we have to know are the prefixes. Know 1 to 10 because you do not have to balance any of the charges. I repeat, for covalent compounds, do not balance charges. Covalent compounds consist of 2 nonmetals, as we have mentioned before. So the step will be that there is a prefix plus the name of the nonmetal. Next, another prefix plus the name of your nonmetal ending in I. So we have here our first example, diphosphorous pentoxide. You will also hear this as Pentaoxide. The most common form is pentoxide. Our subscript is that di and the pen. Di meaning 2 and pent meaning 5. Once again, we do not have to balance any charges. All you have to notice is that di means 2, so there are 2 phosphorus. The pent means 5, so there is 5 oxygen. So that's it. You're done to balancing charges. You're done, no balancing charges. Your prefixes literally tells you how many elements are there in the compound. So we have N3O6. We'll look at the different subscript and figure out what prefix they need. So R3 meaning tri, and 6 means hexa. So we'll put tri and then the name of the non-metal, which was nitrogen, and then we'll put hexa and the name of other non-metal ending in "ide". So we have trinitrogen hexaoxide. Now, I hope you don't plan on living here without practicing what you have just learned. So this is for now, my dear students. Till next time.